The Abyssal World, the last terra incognita of the Earth's surface. This is by MARIM, Center for Marine Environment Sciences, University of Bremen. The deep ocean floor is the last explored ecosystem on the planet, despite covering more than 60% of the Earth's surface. Largely unknown life in abysmal sediments, from benthic animals to microbes, helps to recycle and or sequester the sinking organic or inorganic matter originating from pelagic communities that are numerically dominated by microscopic plankton. Well, we don't have submarines that can go that far. The ones that can go deepest are those orb-looking scientific submarines that go about 3,000 feet down. So these benthic ecosystems underpin two major ecosystem services of planetary importance: the healthy functioning of ocean food webs and the burial of carbon on geologic timescales, both of which are critical regulators of our climate here on Earth. Researchers from the Norwegian Research Center Norse, Bertnes Center for Climate Research, University of Geneva, as well as from Genoscope France, have massively sequenced eukaryotic DNA contained in deep sea sediments from all major oceanic basins and compared these new data to existing global scale plankton datasets from the sunlit and dark water column obtained by the TERRA Oceans and Malaspina circumglobal expeditions. This provides the first unified vision of the full ocean eukaryotic biodiversity from the surface to the deep ocean sediment, allowing marine ecological questions to be addressed for the first time at a global scale and across the three-dimensional space of the ocean, representing a major step towards, quote, one ocean ecology, end quote. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. With nearly 1,700 samples and 2 billion DNA sequences from the surface to the deep ocean floor worldwide, high throughput environmental genomics vastly expands our capacity to study and understand deep sea biodiversity, its connection to the water masses above, and the global carbon cycle. This is what Tristan Cordier says. He's researcher at Norse and Berknes Center for Climate Research in Norway, lead author of the study. Now, what lives in this dark and hostile environment? By comparing sediment DNA sequences with the ones from pelagic realms, it was possible to distinguish indigenous benthic organisms from sinking plankton that had reached the seafloor from the overlying water column. Results indicate that this benthic biodiversity could be 3 times larger than in the water masses above, and this diversity is composed of very different taxonomic groups that are mostly unknown. We compared, they said, our deep sea benthic DNA sequences to all references sequences available for known eukaryotes. Our data indicate that nearly 2/3 of this benthic diversity cannot be assigned to any known group, revealing a major gap in our knowledge of marine biodiversity. So 2/3 they don't even know about. This is what Jan Pawlowski, professor at the Department of Genetics and Evolution of University of Geneva and Institute of Oceanology of Polish Academy of Sciences, said. What can plankton DNA in deep sea sediments tell us? Analysis of the abundance and composition of plankton DNA in deep sea sediments confirmed that polar regions are hotspots of carbon sequestration. Moreover, the composition of the plankton DNA in sediments predicts the variation of the strength of the biological pump, an ecosystem process that transfers atmospheric carbon dioxide into the deep ocean, hence regulating the global climate. So we see that the oceans play a tremendous role in clearing up the carbon dioxide. They said, for the first time, we can understand which members of plankton communities are contributing most to the biological pump, arguably the most fundamental ecosystem processes in the oceans. This is what Colomban de Vargas, researcher in CNRS in Roscoff, France, says. How will the deep sea be impacted by global changes? This genomic dataset represents the first consistent snapshot of whole eukaryotic diversity in the modern ocean. It provides a unique opportunity to reconstruct ancient oceans from the DNA contained in the cumulative sediment record to assess how climate has impacted plankton and benthic communities in the past. They said our data will not only address global scale questions on the biodiversity, biogeography, and connectivity of marine eukaryotes, it also serves as a basis to reconstruct the past functioning of the biological pump from ancient sedimentary DNA archives. It will then inform on its future strength in a warmer ocean, which is key for modeling the future carbon cycle under climate change. This is what Tristan Cordier explained. They said our study further demonstrates that deep sea biodiversity research is of paramount importance. Huge numbers of unknown organisms inhabit ocean floor sediments and must play a fundamental role in ecological and biogeochemical processes. A better knowledge of this rich diversity is crucial if we are to protect these vast, relatively pristine ecosystems from the impacts of possible future human incursions and understand the effect on it of climate change. This is what is concluded by Andrew Goodday, Emeritus Fellow, National Oceanographic Centre, Southampton, who was also involved in the research. So this was from Science Advances, from Marum Center for Marine Environmental Sciences, University of Bremen, on phys.org. Please leave your comments. Thank you for your support. We know that a lot of these, 2/3, we don't even know about what's under our oceans. Please leave your comments. Thank you for your support.